if you multiply the same variable, anything that has the same exponent, you would just add the powers. That's it. So a to the m times a to the n is equal to a to the m plus n. No big deal. Just keep the base and change the powers. There's a list of many different rules, but they're all going to be right here. The exponent 0, now any number, any variable, raised to the 0 power is going to be 1, except the number 0. Everything except 0. But right here, they tell you straight up, 0 to the 0 is not defined. Okay, it's undefined. Everything else is 1. Like 10 million to the 0 is 1. Nothing crazy. That makes sense? Simple rule. That's cool in the first one. All right, the next one, this is the one for division. If you're dividing two variables that are the same base, you'll divide the top one, you'll subtract the power on the top by the one on the bottom. So, m minus the n. It will always be that way. Just be careful with the signs. So like, if there's already a negative there, go minus twice. That might turn into an addition problem. It just depends. So just keep the base, subtract the powers. But sometimes when you're dividing, you may end up with a negative exponent. So the next rule will show you how to deal with it. Let's say you do get a negative. So if it's negative on top, you just move it to the bottom and change the sign. So you just cross the line, change the sign. That's it. Example about this just a moment. So if it's negative on the bottom, you can bring it up top and change it to positive. It's negative already at the top, take it to the bottom, change it to positive. Okay. That makes sense with what you're doing. Picture like a one down here. And you're just moving it to the bottom. That's it. Yes, cool on these first two, or these two right here. Let's look at these right here. The next, the paper. It's the negative 1. So 5 to the negative 1. All I'm saying is bring it to the bottom, make it a positive 1. But you don't have to write the 1, so it just It's gonna be 1/5. Right? That makes sense? Just picture like a 1 down here. Same thing here. Well, there's a negative. So just picture a 1. It's technically always there. X with -3. Yeah. Yeah, straightforward. Now we said on the first rule we wrote down, if we're multiplying the same base, what do you do with these powers? Very beginning. They're the same, you add them, but it's negative, right? So I guess you'd be adding a negative, which is kind of like subtracting. So you would have, keep the base, just add them together. That's it. It's -9 plus 7. -2. How do we deal with this negative? And we do the same thing that we did here, right? Product rule. Deal with negative exponents. Any questions with this first example? A, B, or C? Let me know. Get rid of negative exponents, just cross the line and change the sign. So for example, if it's already negative down here, and bring it to the top. I can forcibly bring it back down, make it negative, or I can bring it up, make it positive. If again, it's negative up here, well, bring it to the bottom. This is how you deal with the negatives. So the formula said a to the negative n is equal to 1 over a to the n. But technically 1 over a to negative n is also equal to this. An additional rule. I'm sure they'll mention it later, but it's technically there. All right. That makes sense, how you deal with the negative exponents. Not a big deal. Okay, yeah, it's cool and I think for this part. So it's pretty much what they did here, right? Bring it down. Get rid of the little number one. It's negative, bring it down again. Same deal. We'll try these three right here just for a sec. 5 minutes. If it's negative, we just bring it to the bottom, right? That's it. So product rule on all three, sum them up. We got -1. Now bring it to the bottom. Any questions on the point? Clear? Number 8. And fourth, and send -3, all divided by this. There's many ways you can do this. Doesn't matter how you start. Just choose something. What would you want to do first? What would you do first? Yeah, we can do product. We see a product up front, right? So, okay, good. 4 plus a -3. That would be 10. Oops, I don't know where that X came from. That'll be 10 to the first. Do next. Yeah, let's try that. We get 10 to the first minus a -2. Product rule. That would be 1 minus is 1 plus 2, correct? But you could have done quotient first. You could have dealt with those negatives first if you wanted to. It doesn't matter. You follow the rules, you'll be good. You choose which one to work with. I recommend doing 2 at a time and then just go from there. You'll be good. Don't try to do it all at once. Like you could have done 10 to the 4th divided by 10 -2, and then that result would be times 10 -3. You could have brought that 10 -3 to the bottom and then 10 -2 to the top, and then did stuff. So it doesn't matter. You'll be fine if you follow rules. You're good. Any questions on 8?
Could you get 1,000?
Yeah, 10 cubed is 1,000. 10 times 10 times 10. That's what they got here. All right. See what they're asking in number 9. Saying you have a hard drive with 2 to the 12 gigabytes. Each project is 2 to the 4, so how many of those projects fit in there? Right. So like, we should be thinking if it was just normal numbers, I should divide. So just divide. And once you begin the division, you'll do the power, the quotient. It's the same stuff. Right? It's like if you said, I don't know, at $20 and each item costs 5, how many can I buy? What would you do? And you would do 20 divided by 5, right? Well, it's the same thing you've done before, they just gave you really strange numbers. So what you would do is take the 2 to the 12 and divide by the projects. This will be that make sense? Yeah, is that weird? Okay. Number 1. What is the answer to number 1? Yeah. You add them up, right? Number 2. Add these up. Keep adding them together. Just remember that if you have a negative, you just put in parentheses and be careful. If you have a double negative, make sure you cancel it. Let's take a short break here. Take a 2-minute break and try working on these questions. I went through 5. Three, you should have got -5 plus -3 is -8. And then you brought it to the bottom. Then this one, can't have the deal, just a number. -5 plus -1. -6 to bring it down. But what is 2 to the 6? All right. I'm just answer your calculator. I think it's 64. 2 to the 6. What happens here? Yeah, they cancel out, right? Anything to the zero? One. Have any issues with those three here? Okay. Fix the quotient. So we'll take the top one, subtracted by the bottom. That should be -8. 1/x to the 8. What about 7 though? What would you try there? Negative. Bring it down. But you don't mess with the 5. There's no power on the 5. There's -9 is on the x. That makes sense. It really looks hard, but it's just messy. Get all the stuff that's the same together, and then just do the power. These are all products. It's 4 times this times that times this. Nothing but times. It's not distribution or anything like that. But pick the numbers that are the same. 4 times -7. Times x -4 times x -5. You don't have to do this, it's just so you can see it. What's 4 times -7? Yeah, 28, right? How do we deal with this?
-9.
So it would be -4 plus -5. Yeah, -9. This one?
What, sorry, why?
Yeah, 1 is 0. We're pretty much done at this point. -4 plus -5 is -9. 2 plus a -2 is 0. This will be gone. It's just the 1. What do we do with the -9? With the x? Yeah, just bring it to the bottom, right? That's it. We're done. That makes sense. You see how just kind of grouping the same stuff together is easier? At first, it just looks like a bunch of garbage. But once you have the x's together and your y's together, numbers, you're just doing the same stuff. Okay. Any questions on 8? On the page in a sec. You guys cool on this page? So over here, they're trying to show you an idea. Notice how here there's parentheses and then over here there's not. So they're different. So if you see -9 squared. What they really mean is that negative is outside. So square first and then apply the negative. What is 9 squared? Remember? It's gonna be 81, but then you have that minus follow you. Just put it in front. See the difference on this one, you're squaring the negative. It'll be negative times negative. This one will be positive. Subtle difference. Or no? Whenever you square a negative, it will always be positive. Just make sure that it's inside. If it's not inside, then it's not going to be. Okay. Section, let's take a 10-minute break. Start this check. So the next rule of exponents is a different set of rules. There's like maybe 10 of them or so. You have a power raised to another power, you multiply it. Okay, so also, if you have a power on multiple things, just apply that power to each one. They already have powers, and you would do the previous. Same. The quotient is really an extension of the product. Same type of deal. If you have a power on an entire fraction, each one gets the power, just like the product did. Okay. There's no real difference. Wait a second.
It's really not fun.
Oh,
Oh, I mean up. I like it. Right there, right there. Thank you.
You guys cool on the rules. Ready? To the first example. Simplify the following. We have a fraction. They both have powers already. You're raising it to another power. The rule, the fraction rule says each one will get that power. That makes sense. I'll rule for a quotient. So we have the quotient. Each one got it. Now, the very first rule says if you have a power raised to another power, what do you do? And we have to multiply the 3 times -4. Same thing for the y. 5 times -4. So that would be x to the -12 over 5 times -4. How do you deal with these negative powers? Rather than they're being divided, whatever the rule says to make it positive, you just move it down, move this one, move it up. Just move it around. That's all you gotta do. I'm gonna move the y to the top. Move the x to the bottom. Does that make sense, or? You can think of it as reciprocals if you want to, but I think it's more simple to just see it as I'm crossing the fraction bar. Move x down and the y up. That's it. Let's look at the method. There are 2 methods. I did method 2. Check it out. I'll put the. So -4 apply to the entire fraction, apply to each. That's what we did. So then you multiply it based on the first rule. It was -12. 5 times -4 is -20. Now we just move the y up top, move the x to the bottom. That's it. Now there's another rule that says you can just flip the fraction and it'll turn into a positive exponent here. Okay. Either way, so either flip it, get rid of the negative and then apply it, or just apply it as negative and deal with it at the end. Either way, it'll be the same. So you get the negative at the beginning or at the end. Okay. Any questions on the first example? Okay. Go ahead and write it out. So you later. Times times 4. Flip it first. That's what I do. But it doesn't matter. With the rest of the order. You guys see these okay? First fourth. I would add a knife rule that's not on there.
What?
Knife rule.
Are we gonna do 12-3?
Yeah.
Same kind of mess.
Yeah, I got the first 8. So the other one. Using the same variables. We have A over B. The negative n. That's the same as B over A. To the n. I don't think that was on there. And then start practicing rules. See how it goes. Fine. The power with another power, what do you do? Yeah, we have to multiply. So what is -3 times -2? Yes, positive, right? And 2 to the 6 is where they got this. Any questions on 5? What did we say earlier? What is anything to the 0? So this is just 1, right? So we don't really have to worry about it. It's just 1. You could apply the rules and go, each one gets 0 and then do it, but you should understand anything to the 0 will be 1. So you don't have to do all that. It's not a big deal. That makes sense? Yeah. 7 with 3x to the fifth. Rounding negative 3. To the negative 3. All right, so what does the rule say when you have a bunch of products?
You disperse the negative column.
Yeah, just put it on each one, right? The negative 2 is just gonna be hanging out. Put it in parentheses for no reason. This 3 gets negative 3. This guy gets a negative 3. This gets a negative 3. That's rule 1 or 2, I forget. Now that you're here, deal with the powers. Worry about the numbers in a second. The 5 to the actually the fifth to the negative 3. What do we do here? Yeah, we gotta multiply, so 5 times negative 3. Negative 2 times negative 3. Okay. So now we're pretty much done. Just deal with the exponents. This would be negative 2 y6. Everything else goes on the bottom. Does that make sense? The ones that had the negatives went across the line. Okay. Three, 7, right? Already here we did our product. Here. We did power rule. Then here to there. With the negative exponents. Are there any steps that didn't make sense? Is that okay? Those rows. Let's do 9 and 10. You guys cool on the page? Rule number 9, just flip it over. After we do that, so we don't have to worry about the negative. And apply the power on top and on the bottom. Numerator gets the 4. Denominator gets the 4. Okay. What happens on top? We're gonna get 3 times 4 on the top. The bottom, they're all gonna get the 4, right? So 2, 4, x2, 4, y 4. To the 4, 16. What is x squared to the 4? Yeah, 2 times 4 would be 8. And that's just a simple 4. First thing we do is rule 9. For that, we did power of quotient. Oh. Rule 9 we did what? Here we did power for the numerator, right? 3 times 4. Then the bottom had a product for a power of a product for the denominator. You got to here. What would you do next? What are the final steps? We're not finished. What do you see?
So the y's, subtract the y's.
Yeah, there's those y's, right? You treat them as a pair. If you divide this y by that y, what would you do?
make one of them negative.
Yeah, you do that minus thing, right? So. Y12 divided by Y4. You could do this. Does that make sense? Or is that weird? That's better. Are there any questions on this problem? If you're doing nothing but, yeah, you shouldn't have any x's or y's at the very end, just one. Okay. We're only doing products and quotients, there shouldn't be any. You just be a single x with a power. Single y with a power. Usually a simple number, but. Not always for the number. You guys cool on number 9? The next one is the hard one. I don't know. This one is just gross looking. What we're gonna have to do is work on them separate. Get a bunch of stuff come out and then see if we can cancel things. So treat them as two separate problems that you're gonna multiply together. Does that make sense? Don't let that hurt your eye. Intimidate you. Yeah. You guys cool if I turn the page? No questions on that? Okay. Okay. Looks like it all cancels out pretty nice. So how do we get there? So. We have a negative power, so we can flip this over, make it a positive. Over here, we could start applying the 3 to everything. So it'd be, I'm gonna put a bracket just so it doesn't look weird, more weird. Be 5 to the third. A cubed to the third. E4 to the third. I skipped a step. Is that all right? Is that, you see what happened? Yeah, let's not do that. Let me show one extra step, just in case. Just in case. So there's a rule in between. If you have power in a fraction, you apply to the top and bottom, then you do the. That was different. So the top gets the 3. Bottom gets the Z. Okay, so I did 2 things on this one, I flipped it over. This guy applied the 3 to the top and bottom. So now I'm gonna apply the 2 on top and bottom here. Okay. The 3 on every single term. Here. That's still with me. Same thing for this one, right? Apply the 2 on every single one. The other one, I'm just gonna copy it and then we'll do it at the same time. All right. So this point, just apply the power. I'll wait a sec because it's a lot to write. Apply the square on every single term. 6 squared. E to negative 4 squared. You agree it's gonna be negative 4 times 2, right? 3 times 2 for the B. Starting to look a little better. 5 squared. 4 to the 2 will be 4 times 2. B to negative 2 times 2. Negative 4. Cool with this first part here. See where the numbers came from? 5 cubed. E to the 3, it's 3 times 3. 4 to the 3, 4 times 3. Negative 2 to the 3, it's negative 2 times 3. Negative 6. Same deal here. Same thing. Okay. Now at this point, you can start dealing with the A's and B's in each section. Then at the very end, just see what multiplies, what cancels. So a to the negative 8 divided by 8, a to the 8. Let's deal with that first. 36 divided by 25, I'm just gonna leave it like this. 8 times the 8 divided by that is gonna be negative 8 minus 8. B to the 6 minus negative 4. They're all technically times. $25 over 2 to the negative 6. A to the 9 minus the negative 6. I'm doing these two A's. B to the 12 minus a negative 6. Technically all times. You guys still with me? I know there's a lot of pieces going on. It's kind of basically making us do every rule that we've done so far, all in one question. It's a good question to practice, but if you haven't like grasped them all yet, then this will feel hard. Okay. So right here, we applied the power to the power, and we got these. And then from here to here, I'm just doing the A's together, the B's together, these A's and these B's. That's all I did. So they were all division, so the minus came from there. Right? These numbers, I just put them on top of each other because I don't want to deal with it. They're just there. Okay. All right. Negative 8 minus 8. 6 minus 4. Be plus 4. Right. Still not dealing with this thing, but we will. 9 minus 6. 12 minus 6 would be plus 6. Okay. All right. Start grouping things that are the same. Group the numbers together, the A's together, and the B's together. Here's the number. It's to the -6, I might as well bring it to the top, right? Make it positive. The A's you can move around if you want, but I'm just gonna write them like this. I'm tired of doing extra steps. Okay, just put them all next to each other, that's all I did. So these are products. Products. All you gotta do is add the powers, and we're pretty much done. So -16 plus 15. 10 plus 18, right? See what the answer is. Are we close or are we off? The B28 and an A, it looks like we got it. Bring this A to the bottom and then reduce this fraction. Just deal the fraction and we're done. So this will simply be 125 divided by 25, that's a 3. Or you can just put this into your calculator, you'll get that 1,000 whatever, I don't know where it is. But you'll end up with a lot of space, 11,520. This is 11,520. Bring the A to the bottom. That B is just hanging out. Okay. I know that was a lot of steps. The same thing over and over again. They just do it a bunch of times. Multiplication, division, powers to power, fraction, it's all the same thing. Back to the easy ones, right? And then this is when you're already kind of good at it, right? Then this will be simple. I wouldn't do this at the beginning, right? That would not be a good idea. Test question number 1. Okay. Oh, let's think about it, think it through. Right? First step, we flipped over into the positive 2. I applied 3 on the top and the bottom on this one, right? Then we applied the 2 on the top and the bottom. I went ahead and applied the 3 on every single piece. And the 3s came out on every single piece. Same thing with the 2s. Every single piece got a 2. There. I left this alone. Then I applied the 2s on every single one. Got us to here. Apply the 3 on every single piece, every product. We got this. Once we got to here, like, okay, well, let's combine the A's, right? Divide the A's, divide the B's, divide the A's, divide the B's. We got these and those, which became these, right? So now just put them all the A's together and the B's together. Multiplication says add them up. -16 plus 15 is a -1. 10 plus 18 is a 28. The A goes at the bottom. There's my B28. This is just some number nobody cares about. It's right there. Okay. That's what we did. Does that help a little bit? All right. hopefully 3 is not too bad. Let's start. Let's go ahead and do this, that way we can. The powers of 10, that's all the rules of exponents on the background. But they're not too great, I like that last. Basically, the rule is. You have a number. A, it needs to be less than 10. Yes, there needs to be one between 1 and 10, and not equal to 10. The little a is. So we use that notation when you have really giant numbers. You bring it down, and you write it this way. So if you had 100 trillion or something, we would write scientific notation. We got a really tiny number with like 30 zeros in front. We would use this. Like if we were to calculate the chances of winning the lottery, we would use this and it'd be negative, very small. So in a nutshell. Here's the light powers approximately 3 times 10 to the 8 meters per second. So it's a really huge number. It's 8 zeros right after. They ask you how many meters per minute does a light travel? So convert it from seconds to minutes. So you're gonna do this a lot in chemistry when you get there. Some of the biology classes will have you convert back and forth. So they're gonna see if you're comfortable. Okay, and if you're already taking it or you're in it now, you know what I'm talking about. It's the only difference is they use ounces, milliliters, pounds, quarts, right? So they can make you convert from something strange like gallons all the way to droplets per minute or something. Okay. And that's just many conversions. Well, let's start simple. Oh, 0.3. Scientific notation. Simplify the question. 3 times 10 to the 8 meters. Into meters per minute. When they say per, like miles per hour, they mean miles divided by hours. Okay, that's what this means. So if you had 20 mph, you put 20 miles divided by 1 hour. So meters per second. Change it to this. So what we're gonna do. How many seconds are in minutes? Not a trick question. Right, so for every 60 seconds, you have 1 minute. We have this fraction that we made is equal to 1 because we have seconds divided by 1 minute. That is the same thing. This is a form of 1. We call these forms of 1 conversion factors. We're going to convert meters per second into this. Okay, so if I had like gallons per ounces or whatever, you would use this as a conversion. So multiply it. Remember that these cancel. I no longer have seconds. That's why I set it up this way. I now have. Put it down here. I now have meters per minute. But I gotta deal with this 60. Can't just leave it there. So let's multiply it out. This is all times 3 times x, or sorry, this x is a times. When you do scientific, they use that symbol. I don't know. But just understand this is 3 times 10 to the 8 times meters times 60. So multiply times 3. Let's put it on further in the front. What's 3 times 60?
180.
Yeah, 180. So we are already in meters per minute. That's what they asked for. Right? What the rule for scientific said, this number in front of the 10 needs to be less than 10. Apparently it's too big. The way I want you to think about it. How many 10s are in here? How do I adjust this? See that 18 times 10 is the same as 180. So now it's smaller, right? If I take out another 10, you agree that 1.8 times 100 is the same as 180? So basically what I'm doing is I'm moving the decimal point. So whenever you move it to the left, there's always a decimal technically there, we just don't write it. So what I want you to do is write it or move it twice. If I move it to the left twice, I end up getting an extra 2 10s. Just add them up. So I have 10 to the 2 times 10 to the 8. How many 10s do I get? You know what I'm saying? Where they're going with this? Now I have this in scientific notation because this is less than 10. So I move the 10s over to this. So instead of having 180, I now have 1.8. It's like I'm divided by 100 and just undoing it right away. Does that make sense? You can do that with any number anytime you want, but we don't because it's weird. The only time we do it or care about that stuff is when we're doing scientific notation. So you have really huge numbers. You want to fix it. Good. So 3 times 10 to the 8 is too big. Writing this out all the time is annoying. So if you're doing calculations, I don't even know what that is. What is that? 300 billion? I can't even see. 1, 2, 3. 300 million. A little big. So this is much simpler. Okay. You can always write a number like this, 500. You know, if I divide it by 100, it's going to be 5. But I can technically write stuff like this into 5 times 10 to the 2. Okay. So these zeros are being counted by these tens. That kind of helps me deal with lots of digits. Does that make sense? So there's two ideas here that we talked about at the same time. So they didn't really explain that here. I just want to give you some more details. But what they said was, well, since there's 60 seconds in 1 minute, just multiply by 60. So then gave us that that 180. Once you have the 180, I had to remove two of the zeros. So I had to move the decimal place twice, because the rule said it is not scientific notation unless your number right there below 10, but bigger than 1. Equal to 1 is fine, but be between here. When it was too big, so we moved it. And then we use the rules of exponents and said if they're the same base, you add the powers, 2 plus 8. That's all we did. Okay. This stuff that I was talking about is just an additional thing that they didn't mention. These are just an idea of conversions. I don't think they're gonna make us do that. Let's see, let's hope not. No, you'll see that type of stuff. Yes. You guys have any questions on this first example? I'm gonna make you do conversions. I want you to see that. That's all. Okay. You have to do it something. Yeah, it's full on page 113 now. All right. Number 5. I haven't seen the answer here. 86 is too big. I need to move it all, move the decimal point all the way to the 8. 8.6 is smaller than 10, right? So what you want to do is remember that there's always a decimal point at the very end. How many times are going to move it? Move it to the left. You need to compensate by adding 10 to the 4. Move it to the left 4 times. Does that make sense? No, it's 6 though. They're moving the other direction. What does that see then? 3, 6, 9. 5, 6. Okay. So I need to move this. 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 2 point, oops, sorry. All the way until you get to the 2. That's 10 spots. And that's what we want to move it. That'll be 2.368. And 10 to the you're right, is a negative exponent. And move to the left is a positive. Okay. And on your calculator, it'll do that for you. We have 2.6 multiplied by a large negative, right? Yeah, it's the only one that works. If you do kind of the -3, it moves it to the left 3 times. Okay. -4 would move it 4 times. But if you see in your calculator these E things, it's basically scientific notation. So whenever you do a huge number like big, they automatically do scientific for 1.3 whatever times 10 to the 11. That's what they're saying. Okay, so the calculator is technically doing that in the background. They're not going to write all those digits. Pick number 7 out. Negative 2. So you can move the decimal place from right there 2 to the left. That's all the numbers. 4.2 times 10 to the negative 2 going to be. You see how there's nothing to move it to? You gotta put your own little zeros there. 1, 2. So this is 0.042. I need that many. I didn't need this one. So if I have negative 2, you go from here, move it twice to the left. If it's positive, you move to the right. Does the main idea make sense? I know it's a lot of topics today. I want to give you Wednesday off. Well, that's okay. Now we can hang out Wednesday. Okay. On number 8, do you see which direction we're going to move the desk? Which way do I go for positive? If you see the zeros going this way, right? Bigger. You know it should be bigger. And we're going to the right. If you know it needs to get smaller, then it's going to go to the left. Negative, it's going to shrink it. Positive is going to blow it up. Try number 9. This is a very small number. So move it to the right. What is our exponent going to be? Positive or negative? Three point zero times 10 to the 1, 2, 3, 4. This guy is what? 1, 2, 3, 4, 5, 6. That'll be 2.5 times 10. -6. Once it's in this form, just do basic multiplication. What's 3 times 2.5? 7.5. Right. So this would be 7.5. -4, oops, forgot my 10 there. So if you multiply 10 to -4 times 10 to -6, what happens to these tens?
You repeat what you said?
I'm just gonna add them up, right? Any questions on number 9? You see what's happening, right? You change the scientific notation, multiply the pieces. And make sure it's still in that form. If you were to multiply and it gets too big, then you gotta move it over again. Okay. 7.5 is small enough, it didn't matter. Like, I don't know. 5 times 3 or something. 15 would be too big, so you have to move it once on this result. So just be careful.